In this example, we're asked to use polar coordinates to find the volume of the solid bounded by the paraboloid z equals to 1 plus 2x squared plus 2y squared, and the plane z equals to 7 in the first octant. The paraboloid intersects the plane z equals to 7 when these two are equal at z equals to 7. So we'll have that 1 plus 2x squared plus 2y squared is equal to 7, which means that 2x squared plus 2y squared is equal to 6. And if we divide everything by 2, we'll have x squared plus y squared is equal to 3. So in the intersection between the paraboloid and the plane z equals to 7 is a circle of radius square root of 3 that is centered at the origin. And we are also restricted to the first octant. So if we want to evaluate the volume between the paraboloid and the plane z equals to 7, then that volume would be equal to the double integral over the disk x squared plus y squared is less or equal to 3. And we're also on the first octant, so x would be greater or equal to 0, and y would be also greater or equal to 0. And now we have, in order to find the volume, we need to subtract the two surfaces, the plane 7 minus the paraboloid 1 plus 2x squared plus 2y squared times dA. So essentially what we need to find is the volume that lies between the paraboloid and the plane z equals to 7. So that would be equal, now since we are in the first octant, the angle goes between 0 and pi over 2. So we have the integral from 0 up to pi over 2. And then the integral r goes between 0 and square root of 3. So the integral from 0 up to square root of 3. And then we have 7 minus 1. And now the 2x squared plus y squared, we can write that as 2 times x squared plus y squared. And this is equal to 2 times x squared plus y squared is equal to r squared. So with that, we'll have 1 plus 2 r to the square. And then dA is equal to r times dr times d theta. So that would be equal to the integral from 0 up to pi over 2. And we now can split the functions of r and the function of theta in their individual integrals. So we'll have the integral from 0 up to pi over 2 d theta times the integral from 0 up to square root of 3 of, now we have 7 minus 1 plus 2r minus 1 plus 2r squared will give us 6 minus 2r squared times r times dr. So that will be equal to the integral of d theta between 0 and pi over 2 is equal to theta evaluated between 0 and pi over 2. And then times the integral from 0 up to square root of 3. And we have, if we distribute r, we'll have 6r minus 2r to the third times dr. So we'll have theta evaluated between 0 and pi over 2 gives us pi over 2 minus 0. And then times integral of 6r dr will give us 6 over 2 r to the square, so 3 r to the square. And then minus integral of 2 r to the third dr will give us 2 over 4 r to the fourth, so 1/2 r to the fourth. And we need to evaluate that between r equals to 0 and r equals to square root of 3. So that will give us pi over 2 from the first term. And then we have for r equals to square root of 3, we'll have 3 times square root of 3 to the square minus 1/2 square root of 3 to the fourth. And then the other term for r equals to 0 is all 0. So we get pi over 2, and then r times square root of 3 to the square gives us 9 minus 1/2 r square root of 3 to the 4th will give us 9/2. So we'll have pi over 2 times 9/2. So that will give us 9 pi over 4. Therefore, the volume between the paraboloid and the plane is equal to 9 pi over 4.